Hey guys, let's look at this one that is a force versus displacement graph here and solve this. It says a net force of F cosine theta acts on an object in the x direction while moving over a distance of 4 meters there along the axis depicted in the graph above. So find the net work done by the force in the interval from 0 to 4 meters there. So remember, on a force versus displacement graph, since force times distance is equal to work or change in energy, then the area under this will be equal to the work done or the change in energy. So let's find these areas. This is a triangle here, so we'll do 1/2 base times height. So 1/2 times 1 times 6 gives us 3. So this area right here represents 3 joules of work. Now here our force is negative, so our area is going to be negative. It's the same triangle there, so this represents negative 3 joules of work done. And then finally over here on this little box, since this is a box, we'll just do length times width or base times height, whatever. So our base is 1, our height is 6, so this is negative 6 joules of work. So when we go to find the net work done, this positive 3 joules will cancel out with that negative 3 joules, and our net work done is equal to negative 6 joules there. So next part here says if the object has a mass of 1 kilogram and was moving with an initial velocity of 4 meters per second, what is the object's final speed? Well, remember, the net work is equal to the change in kinetic energy according to the work energy theorem. So we know our kinetic energy will drop by 6 joules there. Let's figure out how much kinetic energy we had to begin with. That will be 1/2 times mass times velocity squared. So plugging in here, our mass is 1 kilogram. Our velocity was initially 4 meters per second. Don't forget to square it. So 4 squared is 16 times 1 times 1/2 is 8 joules. So we originally had 8 joules of energy. From the work, we will lose 6 joules of that. So that means our final kinetic energy is actually equal to 2 joules. So let's find the final speed. Once again, we'll set that kinetic energy equal to 1/2 mv squared. So 1/2, our mass is 1 kilogram, and we'll be solving for v squared. So divide each side by 1, divide each side by 1/2, and we will get 4 is equal to v squared. So when you take the square root of each side, the final velocity is 2 meters per second.